Your future is here. Dear teachers, parents, students, and everyone, welcome to Hong Kong International Science Olympiad Final 2019 to 2020 and Hong Kong International Computational Olympiad Final 2019 to 2020 online awarding ceremony. HKISO and HKICO are organized by Olympiad Champion Education Center from Hong Kong, a registered educational center on education below of Hong Kong, cooperated with National University of Singapore and US to promote STEM concepts all over the world. This is President OCEC message. Dr. Andy Lam, President, Olympiad Champion Education Center.
Dear all students, parents, teachers and partners all over the world, welcome to Hong Kong International Science Olympiad, HKISO, and Hong Kong International Computational Olympiad, HKICO, final round 2019 to 2020 online awarding ceremony. Under COVID-19, OCEC can only hold online exams. In HKISO, there are 37 gold winners, 50 silver winners, and 45 bronze winners. In HKICO, there are 12 gold winners, 13 silver winners, and 20 bronze winners. Congratulations to all winners from HKISO and HKICO. With excellent performance from HKISO mini experiment and HKICO mini project. On behalf of Olympiad Champion Education Center, we would like to invite more students to share their STEAM learning experience with other students all over the world. Your future is here.
To inspire curiosities and attitudes discovery to promote the understanding that progress has been happening in scientific fields for centuries, to encourage the integrations of ideas and subjects, to encourage truth-seeking, to arouse students to study important scientists who ask good questions and work towards good answers. OCEC all decides to organize Hong Kong International Science Olympiad HKISO. HKISO has its own collector structure, which consists of two main parts. The first task is to finish a paper-based multiple-choice question paper with 4 main categories, such as physics, biology, chemistry, and integrated science. The second task is optional for all candidates is to take a video to share your learning experience on science called Mini Experiment in the Heat Round. Contains paper-based and STEM concept group work at National University of Singapore as scheduled. But unfortunately, under COVID-19, what we can do is to watch the highlight from HKISO Mini Experiment. Let's go! HKISO Mini Experiment Champion.
Primary 2, Andra Ye 2 from ILBC Yangon School, Myanmar.
In this video, I'm going to be showing you how to make an erupting volcano. This is POV potable. This is sodium bicarbonate powder. This is vinegar added with red food dye. This is a glass of water. First, pour the glass of water into the bowl. Mix it thoroughly. It will become a paste if you mix it. Stir it up. Stir it again and again. Now you can shape it into a volcano.
Yeah, we.
After shaping it into a volcano, you can paint it. You can paint it with whatever colors you want. After that, you have to pour the sodium bicarbonate powder into the center. Then pour the vinegar and with red water dye. Wow! It's exploding! The exploded water is called lava. Thank you for watching!
HKISO Mini Experiment Champion Primary 4 Angela Cratton from Talak Living Faith Academy School, Philippines.
Hi, this is Angela, and today we are going to learn about balloon jet propulsion.
3, 2, 1.
But first, I want you to think about this and say if each is true or false. True or false? The movement of a rocket is opposite the direction of the gases being forced out of the rocket. True or false? Rockets can travel better and faster through space where there is no air. We will learn the answers later after we conduct an investigation. Why will a pencil move in the same direction with the force that is exerted on it, but the balloon will move in the opposite direction of the air that is being forced out of it? To answer this problem, we need the following materials: pencil, balloons, string or fishing line, straw, and tape. Lay your pencil on the table in front of you and blow on it. What happened to the pencil? What made the pencil move? Get a balloon, inflate the balloon, but do not tie the end. What do you think will happen when I let go of this balloon? Feed the line through a straw. Tie both ends of the fishing line to stationary objects in the room, making the line straight between the objects. Tape an inflated balloon to the straw. Do not tie the end. Predict what will happen when the balloon is released. Repeat the activity, inflating the balloon with more air and less air, and predict the outcomes. Here's why. The wind was an unbalanced force on the pencil. The pencil started moving because an unbalanced force was applied to it. The greater the force of the wind on the pencil, the faster the pencil moved and accelerated. If you blow forcefully on both a pencil and a heavier cylindrical object, the small mass accelerates faster than the large mass. This proves Newton's second law of motion, which states that if equal forces are applied, smaller masses will accelerate faster than large masses. When the balloon was released initially, it flew in every direction. The balloon moved in a straight line on the string because an additional force was added that held it straight. When air is released from the balloon, the elasticity of the balloon acts as a force on the air inside the balloon, forcing it out. The air being forced out of the back of the balloon pushes back on the balloon with an equal and opposite force. While the escaping air goes backward, the balloon goes forward. Another way to state what happened is to say that for every action, there is an equal and opposite reaction. This is Newton's third law of motion. This answers our question about rockets. Rockets work according to Newton's third law of motion. The third law states that for every action, there is an equal and opposite reaction. In a rocket action, the rocket pushing the gases out. Reaction, the gases push back on the rocket. Just like our balloon experiment, when we blew up the balloon and released it, the balloon pushes air out of the balloon. As this happens, the air also pushes back on the balloon, causing it to move. Now let's go back to learn the answers to my true or false question. True or false? The movement of a rocket is opposite the direction of the gases being forced out of the rocket. True. If the direction of the action is to the left, then the direction of the reaction is to the right. True or false? Rockets can travel better and faster through space when there is no air. True. A rocket can travel faster through space because there is no air resistance or friction to slow it down.
3, 2, 1.
That's all for now. Thank you for watching.
HKISO Mini Experiment Champion. Primary 6 Nat Krishnarat from Computational International School, Phuket, Thailand.
Why do boats float? And how do engineers design it so that it doesn't sink? Let's go find out! Hi, my name is Nat Krishnarat. I am one of the candidates in HKISO 2019 in Primary 6. Today, I'll be experimenting about buoyancy force and I'll prove Archimedes is right about his principle. Let's go and do it! So, the equipment I'll be using is a container filled with water, two smaller containers, A and B, which A has a base area of 82.8 and B has a base area of 156.6. The next thing I'll be using is coins, which will represent the weight put on boats. And the last thing would be a weighing scale. Let's get started. So now we're going to start the actual experiment. But before that, I have made a table to record all the results. Now step 1 would be putting weight onto each container until it equals to 200 grams, 300 grams, 400 grams, and 500 grams. Now like this, I have put weight until the total weight of container A equals 200 grams. Step 2 would be putting the container onto the water. And step 3 would be measuring the height of the container above the water level to find the sinking depth by using this formula. Now I got about 5.4. Now to find the sinking depth, we have to minus 5.4 from the total height of container A, which is 7.8. 7.8 minus 5.4 equals 2.4. Quick maths. So I'm going to write 2.4 centimeter here, like this. Now I'm going to fill in every one of these gaps by doing the same thing, but different container and different weight. After I've done all the experiments, I've got these results. Now, after that, I've applied the results to the buoyancy force formula of Archimedes, which is the sinking volume of water times the density of water, which also equals to the sinking depth times the base area of each container, times the density of water, which I assume that it is 1.0 gram per centimeter cube. And these are the results I got. Now, in theory, they should balance out, or I say it should be equal. However, I have made some errors, like I may have measured the sinking depth wrongly, or there might be the mechanical problems on the weighing scale, or the weight put in each container wasn't balanced out as it should be. So that is why I've got these results. After this, I'll be plotting a graph to show the pattern so that you can see how it links to each other. Let's go see how it looks. And this is how the graph looks like. You can see that it makes some kind of a straight line. However, if you look closely, it is not exactly a straight line. You could also see that the more the total weight, the height, the more the sinking depth. And if you compare container A and B, when the total weight is same, you would see that container A has more sinking depth than container B. And that is because container A has a smaller base than container B. However, if you compare the sinking volume of each container together, you would see that it would be very similar, like this. For example, if the total weight was 300 grams, the sinking volume of A would be 298 and B 297, and it is very similar. So in conclusion, I can summarize that Archimedes' principle of buoyancy force is valid and very useful. And if I were an engineer or a designer that has to design a boat that has to carry a lot of weight, I would know exactly how the size should be and how it would look like. Thank you. I hope you enjoyed this video and thank you for watching. Eureka!
HKISO mini experiment for runner-up. Senior secondary group. Jarend Bakani from Don Honorio Ventura State University, Philippines.
Hi, I am Jaren F. Bakani from Don Honorio Ventura State University, and today we'll be dealing with two mini experiments, which are paper towel dry underwater and water bends straw science experiments.
There must be enough water in the container for you to completely submerge the glass. Next, tear off a section of paper towel and stuff it into the bottom of the glass. Carefully turn the glass upside down. Ensure that the glass doesn't tip to the side. Pull the glass straight out of the water. Ensure that the glass doesn't tip to the side. Once you remove the paper towel, you will find that it is still dry even though you just submerged it in the water. The reason we used paper towel is because it has absorbent quality. Even though the paper towel was underwater, it stayed by. This is because of the air that also in the glass. When the glass is lowered into the water, the air is trapped inside and has nowhere to go. Because of this, the air molecules pushes out the water. When the air pushes the water away, it keeps the water from touching the paper towel. The force of the air molecules that pushes the water out is called air pressure. That is why paper towel stays dry. Observe the straw and notice that it is perfectly straight. Next, place the straw in the empty glass and take note that the straw is still straight. Pour water into the glass until it is nearly full. You will notice that the near top of the water line of the straw appears to bend. When you added the water to the glass, the straw seems to bend. But once you remove the straw, you see it is not really bent at all. This is because the straw is not bending, but the light around is. This is because of refraction. According to history.amazingspace.com, refraction is the light as it passes from one substance to another. The light ray passes from air to glass and back to air. The bending is caused by the differences in density between the two substances.
We don't have to be a professional scientist in order for us to learn something new. Sometimes, you just have to look around and use your things around you to conduct mini experiments. I hope you have learned something new from me. Have a good day.
HKISO mini experiment. First, runner-up, Primary 5, Ramida Saitong from Wat Don Kai Tia School, Thailand.
Hello, I am Ramida Saitong, grade 5 from Wat Don Kai Tia School. This clip I will making a mini experiment with glue slime. Slime is a fluid polymer created by mixing sodium borax and glue. When sodium borax is added to PVA chemical, reaction takes place that makes the long PVA polymer can stick to one another. The long PVA polymer becomes cross-linked, retaining the glue and creating slime. I think the glue is main ingredient for make slime because it's going to be sticky and flexibility. To get started making glue slime, you will need glue, make slime hold together, foaming hand soap, make slime more runny, contact lens solution, make slime more runny, food color glitter, make more fun. experiment was to resist the slab flexible through variation on the amount of water. We want to learn how to make slab and how does amount of water affects the slab flexibility. Comparing it to original research. My finding was that if we use water in resist, the slab is not flexible.
HKISO mini experiment first runner-up. Primary 6 Yan Lin Hurt from Arbor School, Myanmar.
My name is David, and today we're gonna make a rocket. And here are the list of materials you'll need: 2 1-meter 1/2 inch PVC pipes, 3 1-inch 90-degree PVC elbow pipe, 2 1-inch T PVC connector, BBQ igniter wire with crickets, 99% to 100% ethanol, and of course any sized plastic bottles. Now build the frame by using the pipes and the wire as shown in the picture. And now time to shoot the bottle up. So I have some ethanol here. They're 99.99% ethanol. And slowly open it. And be careful with ethanol. They're very dangerous, very flammable, and very explosive. Put them very slowly so that you won't spill any of them. Just put like about the height of the cone that you put here. Just about the height of the cone. And now that you have put some ethanol, get your cap that you threw away. Or if you threw away, then you can use a piece of toilet roll or anything, but don't use your hand, because if the ethanol go on your hand, nothing is gonna happen to your hand. But when you have contact with fire or electric, then your hand can explode, because ethanol is very explosive and flammable. And now we're gonna shake, and now you can see that the volume of ethanol goes down. You'll be able to see that the amount of ethanol in a bottle goes down compared to the ethanol you put in, because some of the ethanol evaporated in here when you shake it. They evaporated, and now these ethanol are in gas form in here. And also you can also see that some ethanol are stuck to the side of the bottle here, and that's good. And now there's still some remaining ethanol in here, so don't throw them away. You can recycle them by putting back in the container. Now there's still some ethanol in here, so all you're gonna do is shake it a little bit. Don't shake it near flammable things, because the ethanol may soak into it and let on fire. And this shaking is very important. It is to let some of the waste ethanol out and let oxygen in, because oxygen is needed to make combustion. And now there you go, we're ready to fire. It's because there's ethanol in the bottle, and this model creates spark, and it reacts with the ethanol inside here, and so there's oxygen in it, and that make combustion and explosion and produce flame, and the pressure inside gets very hot and it just boosts up. Thank you very much for watching this video, and if you haven't, give us a thumbs up and smash that subscribe button. Also ring the notification bell so that you won't miss any awesome content I post. And now have a nice day and bye bye.
HKISO mini experiment second runner-up. Primary 4 Maxim Vinogradov from Head Start Phuket School, Thailand.
So guys, we're gonna charge this beautiful iPhone. I really like this iPhone. And this brand new charger and some wires. I'm just hungry. Very hungry. So this is not actually the original charger, but I think it's still gonna work. So we're gonna use this wire and we're gonna have to strip it. But to strip it, we need these two tools. This tool and a knife. Daddy, can you help me please? Thanks, Dad. This is how it should look like. Wrap around the wire 2 times. So, we're doing the same thing for this wire now. Now we need to put the wire into the lemon. Same thing to the apple. So we plug this wire into the banana. Next. Best for charging, you need to wait about 15 minutes. Yeah guys, it's been already enough. Let me put it on the floor. Then carefully put it between the banana. Let's check if it's gonna. Oh my god, it worked! Oh my god! Oh my god! I can play Fortnite now! Oh my god, unbelievable! I had no idea that banana actually can charge. So I can play Fortnite right now, as you see.
Safe and sound. I can lift you up.
HKISO mini experiment second run out. Primary 6 Ang Tu Win Hatkal from MLA School, Myanmar.
Guys, welcome to my YouTube channel. I'm Ang Tu from Myanmar. Today I'm going to show you the magic tricks of chemistry. Here are the 6 empty containers. This is the colorless solution. I will pour it. Do you know why these lovely colors happen? Before I start this video, I secretly put 3 drops of phenolphthalein into this cup, and I also put 3 drops of dimethylene into this cup, and I also put 3 drops of methanitrophenol into this cup. To get this purple color, you need to mix the phenolphthalein and dimethylene. To get this red color, you need to mix the phenolphthalein and methanitrophenol. To get this green color, you need to mix the dimethylene and methanitrophenol. Now, I'm going to bleach the colors out. This colorless solution is sodium hydroxide. I will explain you the concept of this sodium hydroxide and the acidic in nature. these are the indicators. I pour a large amount of sodium hydroxide into each of these cups. You know why these lovely colors appear? Because this is the phenolphthalein, this is dimethylene, and this is N-nitrofenol. These indicators react with this sodium hydroxide. And about the colors disappear, I will explain you right now. This is a citric acid. These are the indicators. These indicators react with the citric acid because the citric acid has higher acid than these, so they disappear. For the second part of this episode, the next magic trick for this chemistry is invisible ink. Now I will write some words. Now I will spray with the colorless solution. Thank you very much for watching.
HKISO mini experiment, second runner-up. Secondary 1, Dor Darlin from MCTA School, Myanmar.
Hi, I am Dor Darlin from Myanmar. Today, I'm going to conduct an experiment that is commonly known as elephant toothpaste. This experiment consists of, first, hydrogen peroxide, which is used as an antiseptic to clean wood. Second, potassium iodide, which acts as a catalyst to speed up the chemical reaction. Third, dish soap to trap the oxygen inside the foam. Lastly, food coloring of your choice. Before we start, I need to remind you about the safety measures involved in this experiment. Wear gloves and goggles during the experiment and wash the gloves underwater for 15 minutes. Take note that 80% hydrogen peroxide is highly corrosive, and peroxide available in pharmacy is only 3%. Since this reaction will fizz over, I recommend using a large rectangular plastic container. Now let's begin. First, add the hydrogen peroxide into the graduated cylinder. Then add the dish soap. The next part is optional, but you can add food coloring. Lastly, add the potassium iodide. Don't forget to step away after adding it. As you can see, the reaction occurs instantaneously. The foam generated is hot. So if eye or skin comes into contact with the hydrogen peroxide, skin will turn white from a peroxide burn. When the hydrogen peroxide comes in contact with a catalyst, in this case the potassium iodide, it gives off oxygen. The oxygen is then trapped by the dish soap, producing a lot of tiny air bubbles, which forms large amount of hot foam called the elephant toothpaste. Once the foam is cooled, Clean up the foam and rinse it down the drain. Thank you.
HKISO mini experiment, second run out. Secondary 3, Victor Dijasli Pisitgun from Romadi International School, Thailand.
Hi, I'm Victor, and today I'm going to show you guys a simple experiment to help demonstrate the Mpemba effect. So the items you need for this experiment are deionized water, since ionized water might affect the cooling of the water that we're using. Then you also need some tape, a marker, and a thermometer, and also a few bottle caps. So the first thing you need to do is you have to label those 3 bottle caps with one hot, one cold, and one control. So, for example, I'm going to label one of my bottle caps control. Okay, so that worked, and I'm going to just cover it with a piece of tape so it doesn't get caught with the condensation. So then afterwards, you'll pour in hot and cold water into their respective bottle caps. So for my hot water, it's going to be approximately 80 degrees Celsius, while my cold water will be approximately around 20 degrees Celsius. And then I'm going to, for my water for my control, to make sure that my refrigerator is working correctly. And so for that, I'm going to use a thermometer to measure it. As my control is 30 degrees, the temperature is also 30 degrees for my thermometer. So we're just going to go ahead and pour our room temperature water. And now, what you have to do is you have to place this into the freezer and wait and check up in regular intervals of approximately 15 to 20-ish minutes. Between minutes and cold water is not frozen yet. The normal control is not frozen totally yet. However, the hot water is basically frozen right now. Alright, so I have really warm hot chocolate right now. So, I need to cool it down. So, ideally, I would use a means of blowing air to cool it down, like a fan. However, to simulate colder conditions, I use an ice pack as well. So, imagine this is our hot water. So, what's happening is that there's going to be more of this effect of convection, where basically there will be cool air coming down towards the warmer container. Then after that, the cool air will basically warm up, and then as warm air rises, it will go up, and then after that, eventually it will cool down again and pretty much go through a cycle. And this is similar to what's happening right now. It's quickly cooling down our container. This is what is happening to the beaker by convection. Thus, the sides will most notably freeze first, as they are in direct contact with the cycle of cold air that gets warm as it touches the sides and then rises only to get cooler and go down again. This will cause a temperature difference, which causes more convection, since the walls and the water in the inner part are different in temperature, and this leads to convective flow. As it cools, it can be assumed that the convection effect is sustained. However, at 4 degrees Celsius, the cooler water is less dense than the warmer water on top, and thus rises. Convection will decrease as a result of the cool and warm water also mixing. Still, the mixing tends to create a faster cooling time, and thus there's another factor to play, and this leads us to other reasons. Supercooling is like two books. Loosely attached, they can easily separate. And this is similar to water molecules before supercooling. This is since before that, the water molecules are basically not in their strong structure, and thus they need extra time to supercool and then get into their optimal structures before freezing. Like books, these books will get way stronger and way harder to pull apart. If water supercools a degree lower, then there will be more time to make that water freeze, because you have to go down by a degree, an entire degree. And thus, that could possibly make the freezing time of colder water longer, as as hot water could possibly have a higher temperature of supercooling, and it could be easier for it to supercool. Alright, so after quite a while, you can see that the hot water will freeze totally. As you can see here, it's ice, while the control will still have water. As you can see, there are drops. And the cold water will also not be totally frozen. You can see here there's water dripping down. So that pretty much proves the Mpemba effect. So I encourage you guys to try this at home. And thanks for watching.
It is now time to acknowledge the outstanding achievement of all future generation of scientists in HKISO Final 2019 to 2020. Let's start with Primary 2. Primary 2 champion goes to Ma Sofia Isabel Taculineo, Philippines. Congratulations! Primary 2 first runner-up goes to
Tạ Bảo Anh,
Vietnam. Congratulations! Primary 2 second runner-up goes to Frank Tilis Casco, Philippines. Congratulations! Primary 2 Gold Award. Ma Sofia Isabel Taculinao, Philippines.
Tạ Bảo Anh,
Vietnam. Frank Tilis Casco, Philippines. Congratulations! Primary 2 Silver Award. Jana Luis Kinga, Philippines. Johanna Angelique Fautero, Philippines. Congratulations all awardees of Primary 2. Next, Primary 3. Primary 3 champion goes to
รุ้งรินชิน Thailand.
Congratulations! Primary 3 first runner-up goes to Matil Linciego, Philippines. Congratulations! Primary 3 second runner-up goes to
Sheng Jingyao, Hong Kong.
Congratulations! Primary 3 Gold Award.
รุ้งรินชิน Thailand.
Matil Linciego, Philippines.
Sheng Jingyao, Hong Kong.
Sitiga Madev Fernando, Sri Lanka.
Lei Jihong,
Hong Kong. Rafael Taguilinao, Philippines. Congratulations! Primary 3 Silver Award.
Lưu Văn Khánh,
Vietnam. Thamrovi Latana Sunantakul, Thailand. Hans Jacob Vidalon, Philippines.
Nguyễn Hữu Lân,
Vietnam. Achilles Janiel Alvarez, Philippines. Panithi Sunankinpet, Thailand.
Nguyễn Công Nghiệp,
Vietnam. Ovi Gravel Kaluya, Philippines.
Vũ Tú Uyên,
Vietnam. Gabriela Isabel Mercadejos, Philippines. Congratulations! Primary 3 Bronze Award. Torres Alice 12, Philippines. Congratulations! Primary 3 Merit Award. Chris Matthew Murna Villolier, Philippines. Congratulations! Next, moving on to Primary 4. Primary 4 Champion goes to
Đỗ Gia Bảo,
Vietnam. Congratulations! Primary 4 first runner-up goes to Tidas Damsara Ihara Gaman, Sri Lanka. Congratulations! Primary 4 second runner-up goes to Madeline C, Philippines. Congratulations! Next, Primary 4 Gold Award.
Đỗ Gia Bảo,
Vietnam. Tidas Damsara Ihara Gaman, Sri Lanka. Congratulations! Primary 4 Silver Award. Madeline C, Philippines.
Nguyễn Văn Phúc Lâm,
Vietnam. Angelic Clayton, Philippines. Congratulations! Primary 4 Bronze Award. Julia Asuncion Buzos, Philippines. Cedar Mariel Jeans Tanora, Philippines. Congratulations! Next, Primary 5. Primary 5 Champion goes to Gabriel Eden Troy Guanson, Philippines. Congratulations! Primary 5 first runner-up goes to Matthew Defensor, Philippines. Congratulations! Primary 5 second runner-up goes to Jaidi Alicia Alcantara, Philippines. Congratulations! Primary 5 Gold Award. Gabriel Eden Troy, Buoyancy, Philippines. Matthew Defensor, Philippines. Jaidi Alisa Alcantara, Philippines.
Jiu Yuyin,
Hong Kong. Adrian Lance Aller Serrano, Philippines. Sebastian Thomas Abenza, Philippines. Tiratepasit, Thailand. Giovanna Jaden Puitison, Philippines. Tunyapon Lila Sawat, Thailand. Jaanya Hazara Kumaravadu, Sri Lanka.
Zhao Yu,
Hong Kong.
Zhang Palong, Hong Kong.
Cassidy Imera Varon, Philippines. Lance Kenzo Posadas, Philippines. Maria Samantha Cristobal, Philippines. Congratulations! Next, Primary 5 Silverware Award. Yelena Malia Delina, Philippines. Siti Jana Dadu, Philippines. Zira Eliana Gabriel Cuares, Philippines. Colleen La Apilar, Philippines. Michael Craig Singh, Philippines.
Lei Jilong, Hong Kong.
Delisa Francesca T, Philippines. Brian Rorish Lin, Philippines. Amana Ayla Limping, Philippines. Mission Calix Acampo, Philippines. Congratulations! Next, Primary 5 Bonds Award. Brent Anderson D, Philippines. Jadari Lasho, Philippines. John Benedict Castro, Philippines. John David De La Luna, Philippines. Jasmine Losta Belen, Philippines.
Phan Đoàn Minh Hùng,
Vietnam. Congratulations! Next, Primary 5 Merit Award. Alafa Anina Lampe, Philippines.
Đỗ Hoàng Minh,
Vietnam. Jailin Angela Furtado, Philippines. Congratulations to all awardees in Primary 5. Next, Primary 6. Primary 6 champion goes to Laisara Manumita Juvandara, Sri Lanka. Congratulations! Primary 6 first runner-up goes to Wanat Kuwata Waduchi Samitu Risa Asara Fernando, Sri Lanka. Congratulations! Primary 6 second runner-up goes to
Lê Triệu Huy,
Vietnam. Congratulations! Justin Francis Enriquez, Philippines. Congratulations! Next, Primary 6 Gold Award. Laisara Manumita Juvandala, Sri Lanka. Wanakuata Vadu Samitu Risa Asara Fernando, Sri Lanka.
Lê Triệu Huy,
Vietnam. Justin Francis Elegance, Philippines. Mohammed Yassi Nasran, Sri Lanka. Congratulations to all gold medalists in Primary 6. Next, Primary 6 Silver Award.
Trần Bảo Anh,
Vietnam. Abdul Rahman Bantu As, Philippines. Aris Alila C, Philippines. Carlos Jude Lerner Villolia, Philippines. Vincent Joaquin Torres, Philippines. Idolissons Mudiansela Senoli Kerhara, Idolissons, Sri Lanka.
Lao Ho, Hong Kong.
Tạ Tuấn Kiệt,
Vietnam. Siluni Walakulua Lachid, Sri Lanka.
Joanne Kirsten Latselis, Philippines.
Vũ Tạ Thành Công,
Vietnam.
Nguyễn Trọng Anh Minh,
Vietnam. Zachary Thomas Boy, Philippines. Craig Sabin C, Philippines. Congratulations, all silver medalists in Primary 6. 2006 Bronze Award.
Lê Hiền Trang,
Vietnam. Angelica Mendoza, Philippines. Asnifa Maharani Los Makakan, Philippines. Jacob Emmanuel Perez, Philippines.
Khúc Nguyên Bình,
Vietnam. G-Cell Arts, Philippines.
Đỗ Gia Huy,
Vietnam.
Ngô Văn Quang Minh,
Vietnam. Raid Aliana Sac, Philippines. C. Losario, Philippines.
Dương Thành Vinh,
Vietnam. John Manuel Ramos, Philippines. Congratulations to all bronze medalists in Primary 6. Primary 6 Merit Award.
Nguyễn Phan Nhật Minh,
Vietnam.
Đặng Văn Cường,
Vietnam.
Phùng Bá Công,
Vietnam. Isabella Mary Vituola, Philippines. M.N. Sandev Imzara Harat, Sri Lanka. John Lane Centino Villa Leicester, Philippines. Next, Secondary 1. Secondary 1 champion goes to
Wang Kahang, Hong Kong.
Congratulations! Secondary 1 first runner-up goes to Ravija Kritika Amaranzine, Sri Lanka. Congratulations! Secondary 1 second runner-up goes to Vidal Omak Kumaravadu, Sri Lanka. Congratulations! Secondary 1 Gold Award.
Wang Kahang, Hong Kong.
Congratulations! Secondary 1 Silver Award. Ravija Kritika Amarazane, Sri Lanka. Vidal Omar Komaravadu, Sri Lanka. Congratulations! Secondary 1 Bronze Award.
Phan Ngọc Thùy Dương,
Vietnam. Sergi Mateo So, Philippines.
Nguyễn Khánh Linh,
Vietnam.
Bùi Ngọc Phương Bối,
Vietnam. Alex Nathan Longo, Philippines. Gabriel Michiko, Philippines.
Nguyễn Đăng Khiêm,
Vietnam. Francis Maxwell Quanico, Philippines. Rachel Guibay, Philippines. Congratulations! Secondary 1 Merit Award.
Vũ Lê Minh,
Vietnam.
Đinh Tuấn Khang,
Vietnam. Ovi Ginel Kaluya, Philippines.
Nguyễn Viết Dũng,
Vietnam.
Nguyễn Hồng Châu,
Vietnam. Victor Christian Israel, Philippines. Idania Angeline Fartado, Philippines. Congratulations, all awardees of Secondary 1. Next, Secondary 2. Secondary 2 champions goes to
Phan Đức Anh,
Vietnam. Congratulations! Secondary 2 first runner-up goes to Sayuri Ratnayaka, Sri Lanka. Congratulations! Secondary 2 second runner-up goes to
Zhao Yuyin, Hong Kong.
Congratulations! Secondary 2 Gold Award.
Phan Đức Anh,
Vietnam. Sayuri Ratnayaka, Sri Lanka. Congratulations, all gold medalists in Secondary 2. Next, Secondary 2 Silver Award.
Zhao Yuyin, Hong Kong.
Ganad Kevin Lavindu Bandara Ranatanga, Sri Lanka.
Đặng Thái Duy,
Vietnam.
Giác Ngọc Hưng,
Vietnam.
Nguyễn Hương Lan,
Vietnam.
Hoàng Nhật Minh,
Vietnam. Congratulations, all silver medalists in Secondary 2. Secondary 2 Bronze Award.
Bùi Sơn Tùng,
Vietnam.
Nguyễn Hoàng Nam,
Vietnam.
Võ Phan Phượng Hy,
Vietnam. Slater Pagyal, Thailand. Sanuba Vimsat Marapana, Sri Lanka.
Nguyễn Thanh Phong,
Vietnam. Congratulations! Secondary 2 Merit Award. Malia Antionet Lopez, Philippines.
Vũ Hà Linh,
Vietnam. Congratulations! Next, Secondary 3. Secondary 3 Champion goes to Victor Dijasli, Pisitgun, Thailand. Congratulations! Secondary 3 first runner-up goes to Shivani Aisham, Sri Lanka. Congratulations! Secondary 3 second runner-up goes to Pati Lanelaj Luchita Disal Patilana, Sri Lanka. Congratulations! Secondary 3 Bonds Award. Victor Dijasli, Pisitgun, Thailand. Congratulations! Secondary 3 Merit Award. Shivani Aisha, Sri Lanka. Patilan Nel Large Lushita Disal Patilana, Sri Lanka.
Lời ca son, Hong Kong.
Australia Labang, Philippines. Ira J. McGagan, Philippines. Congratulations! Next, Senior Secondary Group. Senior Secondary Group Champion goes to Nakandalej Don Hayset Netmal, Sri Lanka. Congratulations! Senior Secondary Group first runner-up goes to Ideally Sinhi, Mudiyan Selej, Nailali, Hisala, Ideally Sin, Sri Lanka. Congratulations! Senior Secondary Group second runner-up goes to Elijah Levi Lu, Philippines. Congratulations! Senior Secondary Group Gold Award. Makandale, Don, Haset, Natemal, Sri Lanka. Ideally seen, Mudiyan Salaj, Nilali, Hesala, ideally seen, Sri Lanka. Elijah Levy Vu, Philippines. Congratulations, all gold medalists. Senior Secondary Group Silver Award. Sitam Dulan Fernando, Sri Lanka. MHM Sandaru Navin Haraj, Sri Lanka.
Le Cha Phong, Hong Kong.
Congratulations. Senior Secondary Group Bonus Award. Jose Nel Andrew, Tumala, Philippines.
Nguyễn Ngọc Mai,
Vietnam. Geraldine Miranda, Philippines.
Trần Duy Phúc,
Vietnam. Atipat Chongbunatham, Thailand. WM Gandati Airu Kumarasiri, Sri Lanka. Arthur Kaleko, Philippines.
Trần Thùy Trang,
Vietnam. Congratulations. Senior Secondary Group Merit Award. Isabella Grabiel, Lomibao, Philippines. Joshua David Cantilla, Philippines. W. Nadi Dinuli was Sri Lanka.
Võ Hoàng Bảo Ngân,
Vietnam. Vinma Namdini Wetasin, Sri Lanka. Chantal Kara Estalis, Philippines. Congratulations all awardees of HKISO Final 2019 to 2020. Next, Hong Kong International Computational Olympiad is an annual competing Olympiad competition in computational thinking, involves using a set of problem-solving skills and techniques that software engineers use to write programs and apps. Hong Kong International Computational Olympiad promotes problem-solving skills and informatics concepts, including the ability to break down complex tasks into simpler components, algorithm design, pattern recognition, pattern generalization, and abstraction. Hong Kong International Computational Olympiad (HKICO) is a unique Olympiad without dividing into grades or lead by scratch. Primary 2 to Primary 4, Bulky, Primary 5 to Secondary 1, Java, C++, and Python. Secondary 2 to Senior Secondary Group, choose one from 3 with mini project to show students computational understanding on Scratch, Bulky, Java, C++, Python through a video on YouTube. Let's watch winners' work. Scratch,
Đỗ Dạ Bào,
Grade T from Everest Primary and Secondary School, Vietnam.
Hello, my name is Lola Bao. I'm 9 years old in grade 3 and is currently learning at Everest Primary and Secondary School in Hanoi, Vietnam. Today I want to show you one of my projects.
Okay.
In my 121 projects, I like the project Chemistry Game version 4.8.1 most. Basically, it's a project that helps understand basic molecules in chemistry. So in chemistry, the recognizing molecules is very important. So I made this project for you. How the project works is that clicking on the molecules make atoms. So here is a list that you can make. For example, if you want H2O, you just have to click on H 2 times and O 1 time. So it displays the result here. If you want hydrogen peroxide, you just click on H 2 times and O 1 time and 2 times. So it displays the result here. If you want salt, you just click on sodium 1 time and chlorine 1 time. It displays the result here. If you want to clear the results, you just click on the clear button. The main code of the project is in the potion. For example, if you want water, you click on H 2 times and O 1 time. So the project will recognize, the code will recognize it. Next, the atom. It makes clones. So you can click on. The clear button clears all the data. Thank you for your attention. If you have any comments, please comment on the project or on my email.
Blocky Ocean Vijayasandra Secondary 1 from Royal International School, Sri Lanka.
I'm Oshin from Royal International School, Kurunegala. I'm learning in grade 7D, and this is my program to check a person's or a group of people's health when they are going or going into a specific event. Okay, so I'll explain this. So you can see a block in here said check to 1. So this check is a variable, and check is going to give us the final conclusion in here. So if check equals 5, print let him or her in, else print do not let him or her in. Okay, so I'll explain it also. Okay, so first we'll go on with this first part. Okay, so this is the maximum body temperature in Fahrenheit. So 99 degrees Fahrenheit. So I have input in here 98.6 degrees Fahrenheit. So this is just a normal temperature I have input. So it gives temperature is not high. Okay. Okay. So if so we'll check whether this is true or false. So this should be false because temperature is not high means in the else part. This is in the else part, so that means it's false. Okay, 99 is not smaller than 98.6, so temperature is not high. Check is changed by 1. Check is changed by 1 because if there's an healthy statement, because no tiredness and temperature is not high means a healthy statement, and have tiredness means an unhealthy statement. So if there's healthy statement in somewhere, that means only 5 healthy statements can be 4 healthy statements can be there, because in this part 1, in this part 1, in this part 1, and the upper part 1. So in here 3 and 4, and first we have to set check to 1, so equals 5. Check equals 5, and yes, check equals 5. That means there are 4 healthy signs, and we have assigned a value in there, so it comes as 5. And if you are a healthy person, check should be equals to 5, so it would print let him or her in. If not, do not let him or her in. Okay, so second one in here is tiredness. Okay, set tiredness to 1. So this is also a variable. Tiredness is set to 1, so I just read this as 1. 1 is not greater than 70, so we can print no tiredness, change check by 1. Okay, this is a healthy statement, change check by 1. Okay, so in these three parts the same thing is happening. So if we should input a value in here where we should check the temperature, and the output is being automatically input to here, so we can even input a value and see whether this is like this or that, but it is practically done like that. And these three parts we should input. Okay, this one, this one, this one. Okay, so I'm not going to separately explain these three. I'm going to explain this one by all these things. Okay, so if you have tiredness, you can input a value greater than 1 or equals to 1. If you have if you have tiredness, you should input a value smaller than 1. Okay, if you do not have tiredness, a greater value than 1 or equals to 1. Okay, a value equals to 1. Okay, if you have cough, you should enter a value smaller than 2. If you do not have cough, a greater value than 2 or a value that is equals to 2. In here, if you have throat pain, a smaller value than 3, and if you do not have throat pain, a greater value than 3 or a value that is equals to 3. Okay, so if you have healthy signs, you're getting no cough, no throat pain, and no tiredness like that. And okay, now it's time to check the output. Okay, so in here I have given some healthy signs, so that means healthy values actually, that gives us the healthy signs. Okay, temperature is not high, no tiredness, no cough, no throat pain, let him or her in, because every factor, actually every category has a, that means all the categories has the healthy sign. So thank you so much for watching.
It's time to celebrate, congratulate for all awardees in HKICO Final 2019 to 2020. Let's start with the outstanding achievement in programming language in Scratch. Champion in Scratch goes to Giovanna Jardin Butisson, Primary 4, Philippines. Congratulations! Another champion in Scratch goes to Yelena Malia Delena, Primary 4, Philippines. Congratulations!
Nguyễn Thành An,
Primary 4, Vietnam. Congratulations! Gold Award in Scratch. Giovanna Jardin Butisson, Primary 4, Philippines. Yelena Malia Delina, Primary 4, Philippines.
Nguyễn Thành An,
Primary 4, Vietnam. Alexei Zach Michael Corres, Primary 3, Philippines.
Trần Hới Lọ,
Primary 3, Hong Kong. Chavisa Thanatham, Primary 4, Thailand. Sean Direction, Primary 4, Philippines. Congratulations! Next, Silver Award in Scratch. Malia Samantha Christabel, Primary 4, Philippines. Ritlabon Sanson, Primary 3, Thailand. Congratulations! Congratulations! Bronze Award in Scratch. Angela Clayton, Primary 4, Philippines. Dahani Surya Perumal, Primary 4, Sri Lanka. Michael Place Sing, Primary 4, Philippines. Pravan Atauda Arashi, Primary 3, Sri Lanka.
Đỗ An Hiếu,
Primary 4, Vietnam.
Tạ Chí Thành,
Primary 4, Vietnam.
Trần Thiên Nhân,
Primary 3, Hong Kong. Congratulations! Merit Award in Scratch. Hoi Pin Lung Lo Chai Pun, Primary 4, Thailand.
Lê Việt Hưng,
Primary 4, Vietnam.
Phạm Trần Cát Tiên,
Primary 4, Vietnam. Thanapat Kit Thanapat, Primary 2, Thailand. Napat Song Pitit Virayakul, Primary 3, Thailand. Kritinan Nintapgao, Primary 4, Thailand.
Lê Đức Toàn,
Primary 4, Vietnam.
Nguyễn Chí Nam,
Primary 4, Vietnam.
Chỉnh Ngài Trinh,
Primary 4, Hong Kong. Next, the outstanding achievement in programming language in Blocky, champion in Blocky, goes to
Đặng Quang Minh,
Secondary 1, Vietnam. Congratulations! First runner out in Blocky goes to
Nguyễn Hoàng Minh,
Secondary 1, Vietnam. Congratulations! Second runner-up in Blocky goes to Praveen Atauda Arashi, Primary 6, Sri Lanka. Congratulations! Second runner-up in Blocky goes to
Vũ Đăng Minh,
Primary 6, Vietnam. Congratulations! Gold Award in Blocky.
Đặng Quang Minh,
Secondary 1, Vietnam.
Nguyễn Hoàng Minh,
Secondary 1, Vietnam. Silver Award in Blocky. Praveen Atauda Arashi, Primary 6, Sri Lanka.
Vũ Đăng Minh,
Primary 6, Vietnam.
Nguyễn Phú Minh,
Secondary 1, Vietnam. Panisala Kositsurangkakul, Primary 5, Thailand. Bronze Award in Blocky. Aurelio Nicolas Luya, Primary 6, Philippines. W.M. Ocean Samoda Vijay Sandrala, Secondary 1, Sri Lanka.
Đặng Kỳ Anh,
Secondary 1, Vietnam.
Nguyễn Minh Đức,
Secondary 1, Vietnam.
Hậu Đầu Hân,
Secondary 1, Hong Kong. Phum Chai Thien Thamachak, Primary 6, Thailand. Merit Award in Blocky.
Hoàng Ca Hận,
Secondary 1, Hong Kong. Lani Jasmine Gunning, Primary 6, Philippines. Suyuru Nizara Bandara Jayatilaka, Primary 5, Sri Lanka. Patiranil Laj Tinuli Rishka Patirana, Secondary 1, Sri Lanka.
Nguyễn Nhật Minh,
Primary 6, Vietnam.
Khóc Minh Yu,
Primary 6, Hong Kong. Jasmine Losita Belen, Primary 5, Philippines. Marie L. Antoinette Montano, Primary 5, Philippines.
Lục Sở Him,
Secondary 1, Hong Kong. Ethan Hall, Primary 6, Thailand. Lav Benedict Bolanos, Primary 5, Philippines.
Siêu Yu Yin,
Primary 5, Hong Kong. The outstanding achievement in programming language in C++. Champion in C++ goes to Shuran Yu, Secondary 2, Thailand. Congratulations! First runner-up in C++ goes to
Lâm Trạc Phong,
Senior Secondary Group, Hong Kong. Congratulations! Second runner-up in C++ goes to
Vũ Minh Quang,
Senior Secondary Group, Vietnam. Congratulations! Gold Award in C++. Churan Yu, Secondary 2, Thailand. Silver Award in C++.
Lâm Trạc Phong,
Senior Secondary Group, Hong Kong.
Vũ Minh Quang,
Senior Secondary Group, Vietnam. Bronze Award in C++.
Trong Ngày Trần,
Secondary 3, Hong Kong. John David McNay, Secondary 2, Philippines. Ian Savwadalaman, Secondary 3, Philippines. Roy Victor Roberto, Senior Secondary Group, Philippines. Merit Award in C++. Siwakon Kosawitit Kun, Secondary 2, Thailand. Patiran Nihelas Lushita Disal Patirana, Senior Secondary Group, Sri Lanka.
Thẩm Ca Diệu,
Secondary 3, Hong Kong.
Vũ Việt Khánh,
Senior Secondary Group, Vietnam. Alex Nathan Longo, Secondary 1, Philippines. Alexis Griff Ginovatin, Secondary 2, Philippines.
Đinh Thành Đạt,
Secondary 2, Vietnam. Next, the outstanding achievement in Java. Champion in Java goes to Jose Nel Andrew Tumula, Senior Secondary Group, Philippines. Congratulations! First runner-up in Java goes to TR Gachela Tabanao, Secondary 3, Philippines. Congratulations! Gold Award in Java. Jose Neil Andrew Tumala, Senior Secondary Group, Philippines. Bronze Award in Java. T.R. Gachela Tabanel, Secondary 3, Philippines. Congratulations! Next, the outstanding achievement in programming language in Python. Champion in Python goes to
Nguyễn Mai Nhật Anh,
Secondary 2, Vietnam. Congratulations! First runner-up in Python goes to
Lưu Công Thế Hiển,
Secondary 1, Vietnam. Congratulations! Second runner-up in Python goes to
Nguyễn Tuấn Anh,
Secondary 2, Vietnam. Congratulations! Gold Award in Python.
Nguyễn Mai Nhật Anh,
Secondary 2, Vietnam. Silver Award in Python.
Lưu Công Thế Hiển,
Secondary 1, Vietnam.
Nguyễn Tuấn Anh,
Secondary 2, Vietnam.
Đặng Quang Anh,
Senior Secondary Group, Vietnam. Alion Santiago Gonzalez, Secondary 3, Philippines. Lamanayaka Mudiyan Selash Medindu Manuja Jayasekara, Secondary 3, Sri Lanka. Bronze Award in Python. Daniel Dave Cruz, Senior Secondary Group, Philippines.
Hà Huy Trường Anh,
Secondary 2, Vietnam. Merit Award in Python.
Võ Long,
Senior Secondary Group, Vietnam. Tiaranai Tian Thamachak, Senior Secondary Group, Thailand. Pantawat Sapmani, Secondary 3, Thailand. Lesara Manumita Jivanera, Secondary 2, Sri Lanka. Once again, congratulations on your well-deserved success in HKISO and HKICO Final 2019 to 2020. See you next year.